what we decided on, a ping pong launcher. So it's a remote controlled device that moves, and it has a turret that is able to turn left and right. It can fire ping pongs about 7 feet. We could go further, but we were limited by the amount of pressure and the volume that is allowed through this restrictor past the tank. We had to regulate it down to about 100 psi, because any faster than that, it would break the actuator. Other than that, it works really well. We went through many iterations of the 3D printing model through the first design, which was just a holder that was meant to close. And then we went to the second design, which was going to have a 5-volt actuator, and it was going to drop down from the top. And then eventually to what we eventually did was the barrel that goes in and out. It solves two problems at once. It allows it to be only one direction with the airflow. So we had to drill holes in the back so the air flows only forward. And the actuator doesn't put out enough volume of air to shoot it forward. If it was a sealed container, that's why we had to open it up. And it allowed it to push it as well as suck air out of the back and project it forward about 7 feet. I designed the 3D print model stuff and also the programming and all the motor shoes. Dalton designed.
I helped design the solenoid that we originally started out with a 5-volt, but for the design we had to go to a 12-volt solenoid. I also helped with the hopper. We tried multiple different ways to load the balls into the barrel. We even tried a milk carton at one point, and it just kept loading 2 balls in the same barrel. So we kind of switched to the pipe, and it worked pretty well from there. So, and then, Cam?
So I was in charge of building the actual frame itself and stuff. So basically, we had to think of a way that it could be durable and we'll be able to hold the turret, because the turret itself is kind of pretty heavy. So we had to figure out a way to be durable and have a wide enough base to where it wouldn't tip over whenever we were driving it or turning the turn or whatever. So we also had to make the inside big enough to hold the air tank on top of that too as well. So
I helped out with building the actual turret part. As they said before, we went through a lot of different iterations for the loading mechanism. And at one point we had considered having a metal plate that would slide back and forth to keep the too many ping pong balls from falling in. We eventually wound up with the finished product here. We had to make some other adjustments to it to keep the turret from falling too far forwards due to the weight of the actual turret and not being counterbalanced. And you're up.
Thank you. I helped build the reloading mechanism, which is just all this right here. And then also the circuit that fires the entire thing. So it's a duct taped under here somewhere. Yeah, right there. So all that is a relay that goes from 8-volt from the controller to 12 volts in a battery pack, which is also hidden by a bunch of wires. And then added a dead stop or switch right there that turns off the firing so it doesn't just keep going. So about it.
Yep.
There you go.
We had a few other improvements. Torque ratio instead of direct. So there's a smaller gear that this motor is attached to instead of the large gear, because the large gear it often let the turret fall. So with the torque ratio of a small gear to a large gear has a much stronger, it's a little slower, but the motors were plenty fast enough for how fast you want to move a turret. We also then ended up doing that also for the turning left and right for the turret. As far as the barrel itself, his design for allowing it to go forward and back was pristine, allowing it to do that because it solved two problems at once. One, loading one ball at a time, and number two, being able to restrict all airflow other than forward momentum. That allows it to fire further. And also, he helped me a little bit with the programming. We were able to do a double burst of air. For some reason, we haven't fully figured out why. It is much better shooting 2 bursts of air than shooting 1 burst of air. 1 burst of air goes about 3 feet, 2 bursts can go about 7. Also, we want to demonstrate the machine. So, the turret cuts about a 60-degree angle with the firing angle. There it goes. That's the,
Yeah.
of course. A demonstration. What? As I said, you can crank up the pressure, but the actuator's not ready for any further pressure. So you could actually shoot the ball farther. Only problem is you wear out the actuator to the point where it wouldn't work anymore.
Well, and how long, tell her a little bit about what problems you had just getting the balls to
Oh,
reliably.
yes. So some of the biggest problems were the actuator volume that it allows through and the restrictor on the back, as I explained earlier. It actually shoved the ball forward, but it didn't have enough volume to fill the entire space of the tube, which caused it to create a vacuum behind it, which then it pushed forward, created a vacuum, sucked it back, didn't move. It was a nightmare to figure out what was causing it, because you're thinking you're pushing air forward, it's going to shove it forward. But when you have the ball moving forward at such a speed, it doesn't fill the cavity behind it fast enough, so then it comes backwards. And then something as simple as gravity has plenty enough force to hold the ball directly in place. Another thing that kept happening, which was straight bizarre, considering just the random mechanics of it, it actually, when I fired air upon it, the ball sometimes turned into a vortex and just stayed right next to the actuator, even with 100 psi. It just spun and held it up in the air. It was cool to watch, not fun when you're trying to shoot it across the room. That was a few of the iterations. The design work, we had to take this turret apart about 20 times to get it correct. And I went through many different revisions of 3D print models to make it proper.